Hello there and welcome back to another video. I've recently had an idea for a project that I want to build, and while researching the idea and thinking about what parts I'll need and where to source them, I realized that I would need a big power transformer for this project. The thing with large transformers like this that have a decently high voltage center tapped secondary coil and are capable of providing about 4 to 5 amps of current on the output is that they're really expensive. However, that's when I had a really good idea. I could salvage a transformer from an old device that I can get for cheap, and then I can use that transformer in my project. So, what device has this kind of transformer in it and is readily available at places like thrift stores? That's right, old AV receivers. These receivers generally have several channels of decently high power amplification in them, which requires a solid positive and negative voltage rail to power. These voltage rails are almost always acquired by using a big transformer with a decently high voltage center tapped secondary coil that can provide several amps, which is precisely what I need. So I went out and got some old audio amplifiers that I could pull some transformers out of. However, while I was looking around inside the amplifiers, I realized that there's actually a ton of really awesome stuff inside of them that you can salvage. So although I already made a salvaging video recently and don't want to sound like a broken record, I decided that I want to make another one about these amplifiers in particular because they're truly gold mines if you're into electronics as a hobby. Plus, they have some different parts in them than things like computers will. And if you're into electronics and building things, allow me to introduce you to another possible gold mine for you, the sponsor of today's video, PCBWay. PCBWay is a manufacturer of high-quality custom parts. They have several different manufacturing services that they offer, some of them being PCB production and assembly, of course, as their name would suggest, but they also offer 3-axis and 5-axis CNC machining, versatile 3D printing services with tons of different processes and materials, as well as sheet metal production, which, by the way, I used recently, and wow, is that an awesome service. If you're into making things, which you probably are if you're watching a video about salvaging parts to use in projects, you should absolutely check out PCBWay at the link in the video description. Back to the AV receivers though, the first part that I took out was the part that I initially was aiming for, the transformer. Of course, this is one of the best parts in these devices to salvage, as transformers can be expensive new, and this AV receiver cost me $12 at a thrift store. Therefore, I got a nice, big power transformer for $12, and I haven't even tallied up the rest of the parts in here. With the transformer out, I started to remove all of the smaller PCBs that were dotted around the amplifier. Most of these PCBs are just in charge of switching the inputs and outputs of the amplifier, and unless you're into RCA jacks, there's not that much on these boards that's worth salvaging. However, because there are so many boards in these old units, especially if you scrap a few units like I'll be doing today, make sure to hang on to these boards so you can sell them at a recycler for scrap money. Plus, it's usually not legal to just throw out PCBs in the regular trash due to the harmful compounds that they can contain. With all of the smaller boards out and the back panel also removed, I could access the main circuit board of this amplifier, which is where the real goodies lie. Also, I can now get at the big aluminum heatsink and take it out of the amplifier. And this thing is definitely worthwhile to salvage, as heatsinks can be expensive to buy new, especially large ones like this. But anyway, I removed the heatsink and the main PCB and set them aside. Then I took apart the front panel, and here I got some small boards with some relatively nice switches, as well as a 1/4-inch TRS headphone jack, which is always useful. Then, on the main front panel board, there's nothing really that I'm interested in salvaging. You could salvage the small supercapacitor on here if you wanted that for a project, as well as the encoder, push buttons, or the IR receiver, but none of those components interest me. I do wish that this VFD display was salvageable though, because it looks so cool. However, it doesn't seem like I would easily be able to salvage it due to how many pins are on it, and the fact that the driver circuitry is part of the front panel PCB, and frankly, I don't have the time to reverse engineer it or design a driver board with the salvaged driver chips. After all of the guts were pulled out of the amplifier, I went through everything that I had removed and put aside the stuff that I wanted to work with more later, and had a box for the other parts that were going straight to scrap. I set aside the transformer, heatsink, main PCB, and some of the other smaller PCBs that I had pulled out and that had useful parts on them, like a couple of boards that were mounted to the heatsink and had transistors on them, as well as the boards from the front panel with latching push switches and a headphone jack. There are a lot of components on the main PCB that are worthwhile to salvage, and I'll go over these more in detail later, but in case your amplifier doesn't have all of these components on one big PCB and they're split between different modules, here's what to look for. The big main filter capacitors are always worth salvaging, though I should warn you, these can hold a charge for a long time even after the amplifier has been unplugged. Check out what happened when I cut the two main power wires coming from the power supply circuit when disassembling another receiver for this video. I cut both the positive and negative at the same time, and the capacitors discharged through my wire cutters. I was perfectly fine, but this is why you need to be careful. Thankfully, these capacitors are generally nowhere near the voltages that you'll see in something like a switched mode power supply, however. There are also tons of relays in these receivers, as well as these small standby transformers, which I later measured and found are probably good for about half an amp at 15 volts AC on their secondaries, meaning that they could be quite useful for some small projects. Then there are things like the main amplification transistors and other TO220 packaged components that are mounted on small heatsinks that are absolutely worth saving. Finally, there's also a bunch of useful power resistors in the amplifier circuitry that are worth taking for use in other projects. Oh, and one thing that I forgot to mention earlier, salvaging the power cords from these receivers is always a good move as long as they're in good condition. I had two other AV receivers that I acquired for this video, and I chose to scrap them in a very similar way to how I did the first one. This old Pioneer one was quite interesting to take apart though, because it seems to use dedicated power amplifier chips rather than discrete transistors. And also, its power supply was a whole separate board from the main amplification board. Either way, I went through in nearly the same order as before. I removed all of the small boards that handled I/O switching and the like, and then removed the power transformer. After that, I could remove the power supply board and the main amplification board, and then I pulled the PCBs out of the front panel and sorted through what I wanted to salvage parts from and what could be scrapped. Finally, it was on to the last receiver, which is this old Yamaha. This one's kind of a nice receiver, but when I was messing around with it to see if it worked and might be worth just keeping as a functional unit, it was behaving a little bit erratically. So I just chose to go ahead with my initial plan and take its transformer to use for a project. And at the same time, I'd be salvaging a bunch of other good parts from it. I pulled out a small power supply board and the transformer from the receiver first, which is definitely the biggest and most powerful transformer out of the three that I've now salvaged. Also, take a look at this small power supply board. There's a really nice heatsink here, two voltage regulators, and two massive 10,000 microfarad 16 volt capacitors. Moving on, I pulled out a bunch of the I/O switching boards and radio tuning boards, and then cut the wires connecting the power supply board and the amplifier boards. This is where I should have remembered to check the capacitors for charge, and when I cut the two main power wires at the same time, the capacitors discharged through my flush cutters. I was fine, but again, this is why you should be careful if you're doing this. Anyway, after that minor adrenaline rush, I continued with disassembling the amplifier. I took the back panel off and removed the standby power supply board with the standby transformer, some fuses, a couple capacitors, and a relay on it, which are all worth saving. Then, the main power supply board also has some filter capacitors, a full bridge rectifier with heatsink, and a ton of relays that are worth saving. Plus, if you wanted to, you could absolutely desolder the banana terminals and use them in another project. Next, I removed the two-layer amplifier construction, with the top board seemingly being the preamplifier circuitry and the bottom board being the power amplifier. Both of these boards have components that are worthwhile to salvage on them, with the top board having a bunch of linear voltage regulators and capacitors, and the bottom board having several power resistors and of course the main transistors. I also pulled the heatsink out along with these boards. Lastly, I scrapped the front panel and it was off to the sorting step once more, which, if you've been listening closely throughout this video, you'll already know what I'm looking for on the boards that I want to save things to desolder from. But finally, after a long time of disassembling amplifiers, I was left with 3 big power transformers, 3 large aluminum heat sinks, 3 power cords, and a massive pile of circuit boards that I want to pull components off of. And so, I got to work doing just that. I've already talked a lot in this video, and a lot of it has been decently repetitive so far. So I think that I'll give you a bit of a break from that now, so just enjoy a bit of music while I show on screen the different parts that I think are worth desoldering from these boards as I desolder and test them. Now that nearly all of the important components are desoldered from the boards and are tested using either a multimeter or a component tester, it's time to move on to some of the more difficult components to test. In particular, I'm talking about the transformers. Let's start with the simple standby transformers that were desoldered from the PCBs first. These are about as simple as a transformer gets, as they have a single coil for the primary and a single coil for the secondary. Sadly, when salvaging transformers from devices like this, it's usually impossible to find datasheets for the exact parts that you've pulled out. So, it's time to learn how to test these transformers ourselves. However, before we get into this, there are a few prerequisites. You must know how to use a multimeter to measure continuity as well as AC voltage. You must have a solid base understanding of how a transformer works and how they can be wired. And finally, you also must know how to deal with mains AC voltage, as well as AC voltage that's lower than mains, but is still dangerous. This is because we're going to measure continuity to figure out the basic wiring of the transformers, and then we're going to plug them into mains AC power to measure the voltages on their secondary coils. Working with mains AC can be dangerous, so do this at your own risk, and please make sure you know what you're doing enough to be safe. Anyway, in the case of these simple standby transformers, we know that there are two windings, one primary and one secondary, and that they are both simple windings, no center taps. So let's power the primary with 120 volts AC mains and measure the output voltage. Notably, I was able to figure out which coil was the primary by reverse engineering the traces on the PCBs they were on, but in general, it seems that for these specific standby transformers, the coil with the thinner wire and higher resistance is the primary. After powering the transformer, I measured the voltage on the secondary and found that it was about 15 volts AC. All three of these transformers measured the same in that regard. Now, figuring out how much current these can provide is a little trickier. However, one of the transformers on its PCB had its primary fused at 100 milliamps, which translates to about 12 watts on the primary, and at 15 volts on the secondary, 12 watts would be about 0.8 amps. Then, being conservative and accounting for some losses, I believe I can relatively safely say that these transformers are good for 15 volts AC at roughly half an amp. Moving on from the smaller transformers, let's tackle one of the larger power transformers. I'm only going to go over testing one of them as I don't want to be repetitive, but the same sort of methodology applies to pretty much all the transformers you can salvage from these receivers. The first step to do, since these transformers usually have many secondary windings for different currents and voltages, is to measure the continuity between the different secondary terminals with the transformer unpowered. This will allow us to get a basic diagram of how the transformer is wired, and later we can do voltage checks. Once you have a basic diagram of the coils, you can plug the transformer into mains and use a multimeter to measure the voltages between the different secondary contacts. This will allow you to have a comprehensive diagram of what voltages are available on which outputs of the transformer. After this, estimating current output is actually quite difficult. If there were fuses on some of the secondary coils of the transformer in the amplifier, you can use those fuse values as estimates. However, there's usually just a fuse on the primary, and that's it. So, gauging the exact current of each coil is hard, but we can attempt to estimate it based on the wire gauge of the winding and the overall power rating of the transformer. To get a rough power rating for the transformer, you can look at how many VAs the amplifier is rated for on its back panel. And since most of the power for the amplifier goes through the main transformer, that's a good rough estimate of how much power it can handle. Sadly, getting these measurements through reverse engineering is never perfect, and it's the one true downfall of salvaging transformers. However, you can still get good parts and have reasonable estimates of what they're capable of. I repeated this measurement for the other two transformers, and with that, I'm all done with these AV receiver parts. I can now put them all away in my drawers and hopefully use them for some super awesome projects in the future. At the end of this video, I'll have a screenshot of a spreadsheet that I've created that tallies up the value of most of the components that I desoldered from the PCBs. I didn't count every component, but the ones that were easy to tally up, I did. And you can see just how much value I was able to extract before even taking the transformers and heat sinks into account. I bought these receivers for this video, and I paid a total of about $45 for them. If you can find them even cheaper, and if you can find people giving them away for free or who have left them on the side of the road, they're absolutely worth picking up and pulling components from. Well, that's all that I have for you in this video. I hope that you were able to at least enjoy it and maybe even learn a thing or two. In any case, I hope to see you next time. Goodbye.